Hi, mathematicians. My name is Jessica Johnson, and let me share my screen with you real quick. I want to show you that math has a point by talking to you about decimals, real numbers, and proportional reasoning. Question number 1. Write these decimals as fractions in the lowest terms and determine the prime factorization of the denominator in each case. Let's take the decimals 0.225 and 0.036 and turn them into fraction in the lowest terms. Both decimals 0.225 and 0.036 have place values of thousandths. That's with a TH on the end. We know this by looking at the last digit in the decimal number, which is the 5 and the 6. But let's just say you just didn't feel sure about this. That's okay, because I have built you a chart that tells you the place value of the decimal. All you have to do is put your decimal number in and see where your last digit ends. Which column does it end in? Ours end in the thousandth place. Now then that we have our place value established, we know that we're going to put 225 and 036 over 1,000. At this point, it is okay to get rid of the 0 in front of the 36. Let's put these fractions in the lowest terms. To put 225 over 1,000 in the lowest terms, we need to find the greatest common divisor, which is 25. And we get the answer of 9 over 40. The greatest common divisor for 36 and 1,000 is 4. 4 will go into 36 and 1,000, and we get the answer of 9 over 250. And let me skip over my chart real quick. Did you know that there is magic in math? Let me show you what I mean. First, let's start with factoring the denominators of 40 and 250. Factor out 40, and it looks like this. We get 2 to the third times 5. Factor out 250, and we get 2 times 5 to the third. Now, I know what you're probably thinking. You're probably thinking that's not magical to factor out denominators, but let me show you what is magical. Let's factor out our original fractions that we started out with, which was 225 over 1,000 and 36 over 1,000. But first, I only want to look at 225 over 1,000. Factor out 225 and you get 3 to the second times 5 to the second. Now factor out 1,000 and you get 2 to the third times 5 to the third. I have built this fraction over here, and I'm going to look at my numerator and my denominator. And I'm going to get rid of what is repeating. For example, 5 to the second is repeating because it's also in 5 to the third. And we would just get 5. Let me show you. 3 to the second over 2 to the third times 5. And what is 3 to the second? 9. And 2 to the third times 5 is 40. See, we got 9 over 40 when we first began, and we simplified our fractions to the lowest terms. Don't you think that's magical? Now let's look at 36 over 1,000. We already factored out 1,000, so for time purposes, we won't factor it again. We know 1,000 factored out is 2 to the third times 5 to the third. And I'm going to put that as my denominator. Factor out 36, and you get 2 to the second times 3 to the second. And I'm going to put that as my numerator. Get rid of what is repeating, and we'll get 2 to the second over 2 times 5 to the third. 3 to the second is 9. 2 times 5 to the third is 250. Isn't that great? I love it. Okay, question number 2. Suppose that the variables x and y are related by each of the formulas shown below. Create a graph for each formula and make up a reason for the shape of the graph. Here is a list of our variables that we're going to look at. We're going to look at them individually. I gain $2 of interest every month from saving a certain amount of money in my savings account. The graph has a slope of positive 1/2, which is up 2 and to the right 1. This is an increase each month. The 2 represents gaining interest every month, and the 1 represents an unknown amount of money. Let's look at the variable y equals negative x over 2. I lose $2 of interest every month by spending a certain amount of money from my savings. The graph has a slope of negative 1/2, which goes down to the 2 and to the right 1. The 2 represents losing money, and the 1 represents an unknown amount of spending. Let's look at the variable y equals 10x. If I exercise 10 times more for an unknown amount of time, then I will get stronger. The slope shows a positive 10 times, which is up 10 and over 1 to the right. Increased by 10 is gaining strength, and over 1 to the right represents an unknown amount of time. Let's look at the variable y equals x squared. This slope represents my Ford Mustang doubled in acceleration for an unknown distance after I installed my supercharger. The slope has a positive curve that has doubled in an unknown amount of distance. Question number 3. The first square has 12.5% and a fraction of 1/8. But how did I come up with these answers? I took my square and I divided it into equal triangles. When you do this, there's only one triangle that is colored in out of 8. That's how we get our fraction 1/8. Then you take 1/8, divide it out, and it's 1.25. Times it by 100, and you get 12.5%. The second square has a percentage of 38.9%, and the fraction 7/18. Again, I divided my square into equal triangles. When you divide 7/18, you get 0.38 with the 8 repeating. Times that by 100, and you get 38.9%, because percents are parts of 100. The circle is 50%, giving us a fraction of 1/2. I decided to move the red portion to the bottom half of the circle, and I can see that it is equally divided in half. When you divide 1/2, you get 0.5, times it by 100, and you get 50%. I want to show you 3 different methods that you can use to obtain your answers. The first one, you could use a calculator, but what fun is that? The second way, you could use long division. If you'll notice that 7.000 is still 7, no matter how many zeros you put after the decimal. We needed to add zeros because 18 cannot go into 7. Another method is to find a number that you can multiply the denominator by to make it 100. We can multiply 2 by 50 to equal 100. And what you do to the denominator, you must do to the numerator. And we can take 1 times 50 to equal 50. Now we have 50 over 100. Now write down just the numerator and move the decimals from the right to the left 2 times because 100 has 2 zeros. And we get 50%. Isn't that neat? I love it. There's my question 3 explanation. Let's look at question 4. If the area of a yellow hexagon is the whole, then the remaining pattern blocks have areas that are approximately 16.67%, 19.2%, 33.3%, 38.5%, and 50%. Show the block pattern corresponding to the given percent of the hexagon. A triangle will go into a hexagon 1 out of 6 times. This gives us our fraction of 1/6. Multiply it by 100 and you get 16.67%. A tan rhombi will go in 1 out of 5 times. Given us our fraction of 1/5. Multiply by 100 and you get 20%, which is equivalent to 19.2%. But what if we said we had 1 over 5 and 2/10? 5 and 2/10 is the same as 5.2. You could use the chart that we used earlier to come up with this solution to this answer. So 2/10 is the same as 0.2 times 5 to the 2/10 by 100, and you get 19.2%. A blue rhombus will fit inside of a hexagon 1 out of 3 times. This gives us our fraction of 1/3. Multiply by 100 and you get 33.3%. A square will fit inside of a hexagon 1 out of 2 6/10. 2 6/10 is the same as 2.6. Multiplying by 100, we get 38.5%. A trapezoid will fit inside of a hexagon 1 out of 2 times, giving us the fraction of 1/2. Multiply by 100, and we get 50%. Question number 5. There are 3 common types of percentage problems. 1. Given A and B, what percent P of B is A? 2. Given a percent of P in the whole B, what is A if it is P percent of B? 3. Given a part A that is P percent of the whole B, what is the whole B? Well, let's look at this. Part 1 of question 5 is asking you to calculate what percentage of one number is of another. Let's say I have 12 pencils and I give 7 of them away. What percent of my pencils did I give away? We need to take our given information, which is 12 pencils and 7 pencils. So we're going to divide A over B, which is equal to 7 over 12, which is equal to 0.58 with a repeating 3. We're going to multiply by 100, and we're going to get the answer of 58% because we move our decimal point over to the right because 100 has 2 zeros. And here is my poster for part 1 of question 5. Blank percent of 12 pencils equals 7 pencils. Part 2 of question 5 is about calculating a percentage of a number. I need to buy a new car. The car I'm looking at costs $20,520 for the new Toyota RAV4 2019. I want to put 25% of $20,520 as a down payment. How much money would I need? We don't know how much money I will need for my down payment yet, but we know we need to take 25% and times it by $20,520 to figure how much money I will need for my down payment. Take 25 divided by 100 to get a decimal number, which is the same as putting our percent over 100. When you divide 25 by 100, we get our decimal of 0.25. Take 0.25 times it by 20,520 to get the answer, $5,130. I need $5,130 to make a 25% down payment on my $20,520 car. $20,520 car. Sorry. Here's my poster for part 2 of question 5. 25% of $20,520 equals what? There's my beautiful RAV4. Part 3 of question 5 is calculating a number of which a given number is a given percentage. A lady purchased 20% of my handmade wooden signs at the Christmas cottage. The lady received 10 signs. How many signs did I start out with? To figure out how many signs I started with, we need to make an equation of 10 equals 20% times n equals 0.20n. Now, n equals 10 divided by 0.20. Divide 10 over 0.20 and we get 50. I started out with 50 signs. This is my poster for question 5, part 3. 10 signs equals 20% of, and just a little disclaimer, I didn't make these signs that are pictured here. And let's look at question number 6. Create a proportional reasoning scenario. Then create a table and a graph to show the rate of your proportional change. I need to create a table and a graph to represent proportional reasoning. I have several people coming to my house for a Christmas dinner. 1 apple pie will serve 8 people at my Christmas dinner. I have 24 people attending my Christmas dinner. How many apple pies do I need to make? The key to proportional reasoning is ratio. The relationship between 2 variables are always changing in a proportional ratio. This is my table. X represents each pie, and Y represents the number of people. 1 pie will serve 8 people, 2 pies will serve 16 people, and 3 pies will serve 24 people. How do we know this is really proportional reasoning, though? Let me show you. Take Y and put it over X, and we get 8 over 1, 16 over 2, and 24 over 3. Each time we get the answer of 8 when divided out. Equally, you can take X and put over Y, and you get 1/8, 2/16, and 3/24. When you divide these out, you get 0.125 each time. If you didn't get the same answer of 8 or 0.125 each time we divided our ratios, we would not have proportional reasoning. Let me show you my graph. This is the graph. For each pie, I need to make the number of people I serve will increase by 8 times. I will plot a 1 on the x-axis and go up 8 on the y-axis. I will plot a 2 on the x-axis and go up 16 on the y-axis. I will plot a 3 on the x-axis and go up 24 on the y-axis. I connect my plots to represent an increase in the number of pies I need to make to serve my guest. I hope that you have enjoyed learning about decimals and real numbers and proportional reasoning. I also hope that you remember that math really does have a point. And thank you for listening. Bye.